Hello, my students. My name is Wael Salah. I am your math teacher for this session. Okay. The first lesson in algebra is about introduction to complex numbers. Okay. We have studied that to find the solution set of x power 2 equals 25, where x belongs to R, it's already x equals positive or negative root 25, positive or negative 5. So the solution set is negative 5 or positive 5. But if we change the sign of negative 25 as x power 2 equals negative 25, what is the solution set of x? What is the number by itself gets negative 25? There is nothing in real numbers. Okay, so let's expand the real numbers by adding new values as an imaginary values. Okay, real is the opposite of unreal or imaginary. Okay, so let's expand the real set or real number set. So to try to get it, you may add a new symbol to your knowledge base. I power 2 equals negative 1. So let's pretend that any negative 1 equals I power 2. Okay, let's replace negative by I power 2. So x power 2 equals negative 25. Negative 25 is 25 times negative 1, which will be replaced by I power 2. So x power 2 equals 25 I power 2. So any negative 1 replace it by I power 2. You may get the final result or the solution set of x, which is positive or negative root 25 I power 2, which is positive or negative 5. The root of I power 2 is already I. So x equals positive or negative 5i. Again, what is the I? I is an imaginary value. This is not belongs to R. It's an expand of R. Okay? Okay. So x equals positive or negative 5i. So our main rule is I power 2 equals negative 1. So you know right now that I power 2 equals negative 1. So what is the value of I power 3, I power 4, I power 25, I power 50? Let's know. Okay. I power 2 equals negative 1. So the value of I power 3 or I power 4 or I power 5. What is the value of I power 3? I power 3 may be expanded as I power 2 times I. I power 2, which is already negative 1. So negative 1 times I equals negative I. I power 4, which can be expanded as I power 2 times I power 2. Negative 1 times negative 1 equals 1. I power 5 may be expanded as I power 2 times I power 2 times I power 1. I power 2 is negative 1 times negative 1 equals 1. 1 times I equals I. So can you get the value of I power 102? Can you get it yourself? I power 2 times I power 2. Stop. I'll give you the smallest rule for simplify the value of I power 102. Note that I power 4 equals 1. I power 4 equals 1. So any power that is 4 equals 1. So I power 4 equals 1. Okay, let's write a new rule. I power 4n equals what? What's the value of n? Any integer. So, I power 4 times any integer, the value will be 1. Let's test it. I power 4 already 1. Okay? I power 8 equals. Let's expand it as I power 4 times I power 4. 8, 4 and 4. Okay? So I power 4 times I power 4. It is 1 times 1 equals 1. I power 12. I power 4 times I power 4 times I power 4. 1 times 1 times 1 and so on. Okay? Okay. So how can you get the value of I power 102? To simplify more i's. I power 102, let's make a simple step, okay? Let's divide the power by 4 and focus on the remainder, okay? Again, let's try to divide the power by 4 and focus on the remainder, only the remainder, okay? 102 divisible by 4, no, 102 divided 4 equals 25, and the remainder is 2. So 102 equals 25 times 4 plus 2. So any power divisible by 4 equals 1. So the result will be I power 2. I power 2 equals -1. Okay, let's make a new exercise on this part. Simplify. I power 35, I power 125, I power 23. Okay. First of all, let's divide the power by 4. 35 by 4 and focus on the remainder. 35 divided 4 equals 8 and the remainder is 3. So 35 divided 4 equals 8 and remainder 3. Okay? Focus on the remainder. So I power 35 equals I power the remainder. I power 3. In simplest form, okay? So I power 35, why? Because the number which is divisible by 4, it's already equals 1. I power 4 times 8 equals already 1. Okay, let's focus on the remainder. So I power 35, it's I power 3. Okay, by the shortest way. I power 3 equals, let's expand it as I power 2 times I, it's -I. So the value of I power 35 is -I. I power 1025. Okay, let's try to divide it by 4. What is the remainder? Hurry up. Okay, what's the remainder? It's 1. Okay, it's I. I power 23. What is the remainder? What is the remainder? It's 3. So it equals I power 3. What's the value of I power 3? It's -I. Okay? Okay. So any I of any power can be simplified as you saw right now. Okay. What's the relation between I and the title of complex numbers? Let's see. I is an imaginary value, okay? Complex number any complex which is combination of real part and imaginary part. What's the real part? Any number that belongs to R as -2. Imaginary part, any number that's joining the symbol I as 5i. So let's combine them. The complex number which is consists of -2 as a real, 5i as an imaginary is -2 plus 5i. Another one. The real part is 1/3, maybe fraction, okay? The imaginary part is -2/5i, okay? Let's join them. 1/3 plus -2/5i, which is already 1/3 positive and negative is minus 2/5. So the complex number is 1/3 minus 2/5i. Okay? Okay, that's the form of complex number, which is generally a plus b I. So the general form of the complex number is a plus b I. Which part is real? It's a. Which part is imaginary? It's b. Okay. Another idea in this section, it's about equality of two complex numbers. Find the value of A and B. Where? Find the value of A and B where A minus 5i equals 5 plus bi. Okay. The equality of two complex numbers means that the real part equals the real part, the imaginary equals the imaginary, as follows. Okay, what is the real part in this section? It's A. But the real part in the other hand is 5. So, directly A equals 5. What's the imaginary part in the first hand or left hand? It's negative 5i. What's the imaginary part on the right hand side? It's bi. So directly b equals negative 5. b equals negative 5. Okay. More and more, any set has its own operations. When I said the operations, I mean plus, minus, by, divide. What's the operations of the complex numbers, or what's the operations on complex numbers? It's adding, subtracting, multiplying, dividing. Okay? Okay. So, operations on complex numbers. Number 1, 2 plus 5i plus 3i minus 4. What's the value of this operation? complex number plus complex number. How to get the value? Okay, first of all, let's erase the brackets. 2 plus 5i plus 3i minus 4. Okay, let's join the real parts together and the imaginary parts together. Okay, 2 minus 4 equals negative 2. 5i plus 3i equals 8i. So the final result will be negative 2 plus 8i. Again, let's erase the brackets, then let's join the real parts together, the imaginary together. 2 minus 4 equals negative 2. 5 plus 3 equals 8i. Okay, how's the subtraction? Negative 3 plus I minus 7 minus I. Okay, let's erase the brackets. The first bracket will be erased with no problem. Negative plus I. The next one. Negative before any bracket will change the signs that's interior the brackets. Okay. So negative will be change the positive to negative. So negative 7. Negative to negative I, it's positive I. Let's join the real parts. Negative 3 minus 7. Negative 3 minus 7 equals negative 10. And I plus I equals to I. So the result will be negative 10 plus 2I. Okay. Okay. Number 3. Two I minus 1 times 3 minus 3i. What's the result of complex by complex? We know that to get the value of bracket times bracket, you must multiply the first by all and the second by all. Okay, let's try to get the value. 2i times 3 equals 6i. 2i times negative 3i. Positive times negative equals negative. 2 times 3 equals 6. I times I, it's I power 2. Okay. Next one. Negative 1 times 3, it's negative 3. Negative 1 times negative 3i, it's negative times negative positive. 1 times 3 equals 3i. Okay. 6i, let's join the imaginary parts. 6i and 3i without I power 2. Because they are on similar powers over I. Okay? So 6i plus 3i equals 9i. Okay. But what is the value of I power 2? As I said before, I power 2 is the value of negative 1. If you solve I power 2, you may change it by negative 1. Okay. So I power 2, it's negative 1. Negative 1 times negative 6 is 6. Okay. 6 minus 3 equals 3. So the final result will be 9i plus 3. The complex number may be written as imaginary plus real or real plus imaginary. They are the same. Okay, you have studied the conjugate numbers and prep 2, and let's move to the secondary one. The conjugate numbers of the complex numbers is a plus bi. The conjugate of a plus bi is a minus bi. So the conjugate of the complex number is focusing on the sign of I, sign of the imaginary part. Okay, so a plus bi is a conjugate of a minus bi. Okay, the conjugate number of 5i minus 2 is, let's choose 5i plus 2, negative 5i minus 2, 5i minus 2, 2 minus 5i. Okay, what's the complex number? It's 5i minus 2. What's the conjugate of 5i minus 2 without seeing these answers? I said that the conjugate is focusing on the sign of the imaginary part. Okay, let's change the sign of the imaginary part. 5i, let's change it to from positive to negative. So the imaginary will be negative 5i minus 2. Okay, what's the value of the conjugate of 5i minus 2? It's already negative 5i minus 2, not 5i plus 2. So the conjugate of the complex number is focusing on the sign of the imaginary part, not the sign in between the two imaginary and real. Okay, another one, the conjugate of negative 2i minus 7 is number 1, negative 2i plus 7. Number B, negative 7 plus 2i. What's the conjugate of this one? Okay, do not focus on the answers, just answer yourself. What's the result of the conjugate of this complex number? Complex number is focusing on the sign of the imaginary part. So let's change the imaginary part sign. Okay, it's 2i minus 7. So you change the sign of the imaginary part from negative 2 to positive 2. So the result will be 2i minus 7. What is the complex number here? Why? I said that the complex number may be imaginary plus real or real plus imaginary. So if you swap them from 2i, that's positive, and negative 7, that's negative, the answer will be negative 7 as a real, positive 2i as an imaginary. Okay? Okay. We studied the operations. We studied adding, subtracting, and multiplying. What is about the division operation? Number 4, the division. 5 over I. What's the value of 5 over I? Okay, already we don't accept the denominator that's an imaginary part. Okay, if you saw the denominator is an imaginary, convert it into real parts. How can you get it? 5 over I. Let's try to multiply them by I over I. I over I equals already 1. So 5 over I by I over I, the result will be 5I over I power 2. What's the value of I power 2? I power 2 is already negative 1. So the result will be 5i over negative 1 or negative 5i as a final result. So if you want to cancel the imaginary part from the denominator, just multiply it by I over I. Another one. Negative 2 over 3i. Okay? The denominator is imaginary part. Imaginary part as an I. To convert it into real, just multiply by I over I. I over I, negative 2i. 3i times I, 3i power 2. What's the value of I power 2? It's negative 1, okay? So the value will be negative 2i over negative 3 or 2i over 3, or you may write it as 2 over 3i. They are the same. Okay? Okay. This is about the division over I only. But if you want to divide by complex numbers, this is an imaginary part only, okay? So let's try to make a division on complex number. That's more professional. Five minus I over 2 minus 3i. What's the value of 5 minus I over 2 minus 3i? To erase the imaginary part in the denominator or complex part in the denominator, just multiply by. In the imaginary, we multiply by I, but in complex number, we will multiply by the conjugate number that's studied before this section, okay? So, what's the conjugate of the denominator? 2 minus 3i, it's 2 plus 3i. 2 plus 3i. So, we will multiply both numerator and denominator by the conjugate of the denominator. 2 plus 3i over 2 plus 3i. Okay, let's make the multiplication operation. 5 times 2 equals 10. 5 times 3i equals 15i. Negative I times 2, it's negative 2i. Negative I times 3, it's negative 3i power 2 over. The benefit of the conjugate numbers in multiplying, that if you multiply the two conjugate numbers, just multiply the first by the first and the second by the second and put the negative sign between them as 2 times 2 equals 4 minus 3i times 3i equals 9i power 2. Okay? Okay. Let's simplify the numerator at first. 10. Okay. Plus 5i. Can be joined. Okay. 2i. Can be. 3i power 2. I said before that I power 2 will be replaced already by negative 1. So, negative 3 times negative 1, it's 3. So, the result will be 10 plus 3. 10 plus 3 equals 13. 15i minus 2i equals 13i. The denominator. 4 minus 9i power 2. I said 9i power 2. I power 2 will be replaced by negative 1. So 9 by negative 9 by negative 1, it's positive 9. 4 plus 9 equals 13. 4 plus 9 equals 13. Okay. So the final result will be the complex number is divided by 13. So the real part is divided by 13, the imaginary part divided by 13 as 13 over 13 plus 13i over 13. 13 over 13 equals 1. 13i over 13i equals 1i, and this is the final result of 5i, 5 minus I over 2 minus 3i. Okay? That's the final part of our lesson today of complex numbers. Thank you for listening, and be happy, and goodbye.